What we need to see here on the graph is a bunch of triangles. So if we let each side length, or each of these distances that we were looking for, be the hypotenuse of a right triangle, then we can, as we've done so many times before, use the Pythagorean theorem to find the length of that side. Conveniently, since we're using graph paper made up of these little tiny squares, we have right angles all over the place. That made drawing these right triangles super simple. If we look at the opposite ends of one of these side lengths, we can just draw lines along the lines that are already given to us by the graph paper, and they'll intersect to help us form the right triangle. Then we just need to figure out the length of each of these legs for each of these triangles. Let's look at leg AB as an example for how to deal with the other three triangles on here. We need to find out the length of either of the two shorter legs in order to find out the hypotenuse. So we can just count 1, 2, 3, 4, 5, 6, 7. 7 is the length of this side. Do the same thing for this side. This is 5. In looking at this modified version of the Pythagorean theorem, we can just say that the length of AB, this hypotenuse, is the square root of 7 squared plus 5 squared. Simplifying that gives us the square root of 74. Once we find the lengths of the legs of all of the other right triangles, calculating their hypotenuses is also easy. And so, at long last, here are our final answers. The length of AB is the square root of 74, BC, square root of 180, CD is the square root of 40, and DA is the square root of 130.